Welcome to the EMQX Cloud tutorial. Today, we're going to look at the message delivered and dropped event topics. These system topics are triggered whenever a message is delivered or dropped, providing details such as the publishing client, the topic, and even the reason why a message was dropped. While standard MQTT clients cannot subscribe to these topics directly, EMQX Rules Engine lets you capture these events, republish them to other topics, store them in a database, or integrate them with external systems for real-time monitoring and analysis. This gives you full visibility into message lifecycles, even though EMQX does not store message history by default. By using these event topics, you can track message delivery from publishing to consumption, detect dropped messages, trigger alerts for anomalies, and analyze throughput per client or topic. For businesses, they provide valuable insights for performance optimization, troubleshooting, auditing, and compliance. Let's take a closer look at the most common and important use case, troubleshooting message loss. We'll start by understanding the concepts. Messages can be dropped in two main situations, during routing or during delivery, and each is captured with its own event topic. During routing, a message can be dropped if it cannot reach any subscriber. This can happen when no clients are currently subscribed to this topic, so there's simply nowhere to deliver the message. It can also occur when the awaiting queue for QoS2 messages is full, preventing new messages from being processed. Another reason is when a QoS2 message arrives with a package identifier that has not been released yet. In this case, the broker cannot handle the message and it gets dropped. Messages can also be dropped during delivery, which means they reached the broker but were not successfully delivered to the subscriber. One common reason is when a client has clean session set to false. In this case, the broker stores the messages for offline clients in a fixed-size message queue, which by default can hold up to 1,000 messages. This queue works in a first-in first-out manner, so when it fills up, older messages are dropped to make room for new ones. If the client stays offline for too long or the session expires, all messages in the queue are cleared, resulting in message loss. To prevent this, you can set clean session to true, so messages won't accumulate while devices are offline. You can also implement automatic reconnection on the client to minimize offline time. Additionally, avoid using random client IDs when clean session is false, because each reconnection with a new client ID creates a new session, which can lead to message loss. Another reason is insufficient client processing capacity. Each client has a fixed-size message queue, and if a client subscribes to multiple topics and the messages accumulate faster than they can handle, some messages will be discarded. To address this, you can optimize the client's subscription handling to process messages more efficiently. You can also use shared subscriptions to distribute the message load across multiple clients. For these two reasons, depending on the message QoS level, the reason field may show queue full or QoS0 message. It may also show no local, meaning clients are not allowed to receive messages they published themselves, or expired, meaning the message or the session has expired. Now, let's see how this works in practice. We'll use these event topics along with the message republish feature to identify dropped messages. You can also forward them to external systems if needed. First, go to the data integration page in your console. Under Data Forwarding category, click Message Republish. In the SQL editor, we'll create a rule to capture message dropped when routing events. This rule extracts key fields from the events, which helps us analyze why messages are being dropped. Click Next to add an action. In the Create Actions tab, keep the default connector as Message Republish and enter Message Dropped for the topic name. Leave the remaining options as their default values and click Confirm to finish the configuration. Now, let's test the rule and action. We'll use MQTT to simulate a client named pub. Subscribe the pub client to the topic message dropped so it can receive our republished messages. Next, send a message to topic test using this client. Since no client is subscribed to this topic, the message will be dropped. You'll see the pub client receives a message showing the client ID, topic, QoS, timestamp, and the reason as no subscribers. From this demo, we can see how these event topics make it easy to troubleshoot message loss and gain visibility into both routing and delivery issues. In conclusion, the message delivery and dropped event topics provides comprehensive, real-time visibility into message flows and the reasons behind any message loss. These events can be integrated with external systems for monitoring, analysis, and auditing. By leveraging the rules engine, you can track message delivery, promptly identify and troubleshoot issues, and ensure efficient and consistent operation of your MQTT environment. Thank you for watching, and for more detailed guidance, please check out the official EMQX Cloud documentation.